Oxygen safety. There are many regulations regarding oxygen safety, the main one being the Health and Technical Memorandum 0201, the Health and Safety at Work Act, the NMC Code of Conduct, and many NPSA alerts. The main guidance say all staff who use oxygen must be trained in its use and refreshed annually. Healthcare professionals should reduce the risk of harm to patients by ensuring that they are fully competent to undertake any task they do, which includes the administration of any medical gases. There are many stakeholders involved with medical gases, from the engineers to the porters to the pharmacists, the registrant, up to and including the chief executive. It's not just a case of turning a knob and it comes out of a wall. So what's the difference between these two oxygen cylinders? The little white one on the left and the green one on the right from a mechanic's garage. Physically, the gases are not different. However, the medical gas is cleaner and purer and classified as a medical product. It's marketed by a company with a relevant licence and is traceable from the moment it gets put in the cylinder to the moment that cylinder gets delivered back to BOC. Medical oxygen is a drug and it must be prescribed for at drug rounds. At the moment, it can be prescribed on e-meds, showing that patients need to achieve a specific target saturation. In an emergency, oxygen can and must be given without a prescription. So what is an emergency? This is a list taken from the British Thoracic Society guideline for oxygen use in healthcare and emergency settings. However, this list is not exhaustive and clinical assessment is the key to any emergency situation. Every year within Mid-Yorks we undertake an audit counting the number of patients on oxygen and seeing if they've got a valid prescription. The target is 95%. And also 100% of nursing and medical staff should be trained in the safe use of oxygen. Have a think about your area of work. Would you meet the objectives? These are the results for the last 5 years. In 2020, 53% of patients on oxygen had a prescription, which is an improvement on 2019, but less than 2018. Here's a list of the wards and the percentage they attained. As you can see, 4 wards attained 100%. When we re-audited a few months later, 2 wards improved. So how do you think we could improve this on your ward or your clinical area? So what do the lungs do? The lungs' main role is to provide enough oxygen to the blood and clear waste products from the blood. It's achieved by oxygen being moved from the air into the lungs and into the bloodstream. And the breathing muscles move fresh air into and used air out of the lungs. Respiratory failure occurs if the lungs are damaged or the breathing muscles are not able to move air in and out properly. Maintaining enough oxygen in the blood is critical because without enough oxygen, cells in the organs can't survive, which can lead to multi-organ failure and in the long term, right heart failure. We support the lungs with type 1 respiratory failure by using oxygen therapy, target saturations of 94 to 98%, and the scale 1 in the News score. With type 2 respiratory failure, it's cautious oxygen use and the lower saturation range of 88 to 92% and scale 2 in the News. So the purpose of oxygen therapy is to correct potentially harmful hypoxemia. But do remember that breathlessness and hypoxemia are not closely related. Oxygen does have little impact on breathlessness in mildly hypoxemic patients, but it can reduce the work of breathing in more severely hypoxemic patients. But do remember that oxygen does have adverse side effects, so it must be prescribed just like any other drug therapy. So we give oxygen in the short term to prevent tissue hypoxia and in the long term to prevent right heart failure. Some patients are at risk of CO2 retention and acidosis if given high dose oxygen. However, not all of these patients retain CO2. So check with a senior doctor which saturation range is suitable. If you come across a patient who's short of breath, the first thing you should do is ask what they've done. Have they walked somewhere and it's normal for them to breathe in this way? Don't do their saturation levels and start oxygen without talking to them first, because you may find that after a short walk this is what they're normally like and they recover after a few minutes. So please remember, your patients know their chronic illnesses better than you do. So who does what? The prescriber prescribes oxygen and specifies a starting device. They'll adjust the target range as needed. The registrant documents the starting device, starts the oxygen and ensures the target saturations are achieved quickly. They also sign the drug chart. The HCA, student or AP, monitors the oxygen level, minimum of 4 hourly, records the saturations and delivery device, and reports when the saturation ranges are outside the target. So for this to happen effectively, you need to make sure that the target saturation range is the same on ppm plus and EMEDS. The healthcare assistant or student or AP do not start or alter the oxygen flow. So if a patient takes their oxygen mask off, puts it on their bed to have a cup of tea or some food, as long as that oxygen is still running at the same rate, they can then replace the mask. If, however, the oxygen is switched off, they can't. They must have a registrant or a prescriber to start it. Saturation levels are measured using a pulse oximeter. There are finger probes and ear probes. Finger probes should be obviously put on a finger, never an ear and never a toe. Ear probes are placed on an ear. However, they're not as accurate as finger probes. Always make sure that the signal is stable and accurate before writing it down. The other way of measuring oxygen levels is using an arterial blood gas. However, this is invasive and can be very painful. What devices can be used to administer oxygen? Nasal cannula are well tolerated and comfortable. They stay in place and enable your patient to eat, drink and talk to you. However, it is difficult to determine an accurate amount of oxygen that's being delivered. The flow rate can be from 0.5 to 6 litres per minute. If you want to give less than 0.5 litres, you need to get a special flow meter from medical physics. If the saturation level cannot be kept within range, you need to change to a Venturi mask. We still have some simple face masks within the Trust, however they're not an accurate way of giving oxygen. If you're unable to maintain saturation levels, it is better to use a Venturi. We have high concentration reservoir masks, also called non-rebreathe masks. They're good for critical illness and trauma patients because they deliver quite high concentrations of oxygen. The Venturi fixed performance mask are a more accurate way of administering oxygen. The minimum oxygen flow is displayed. So remember, if you have a 24% Venturi in situ, you can increase the oxygen as much as you like, but you'll still only get 24%. If you need to increase the amount of oxygen, you need to change the Venturi. There are times when we humidify oxygen using cold or warm systems. Cold systems, however, are less effective. If you have a patient with a tracheostomy, remember there are specific tracheostomy masks. Within the Trust, we do use high-flow nasal cannula. It's a way of giving increased amounts of oxygen. They are well tolerated and do reduce escalation to non-invasive ventilation and re-intubation. They're used on the acute respiratory care units and are used to good effect. However, due to the high amount of oxygen used, they've not been used as much during the peaks from COVID. Non-invasive ventilation is the use of breathing support administered through a face mask, nasal mask or hood. It's termed non-invasive because it's delivered with a mask that's tightly fitted to the face and the patient doesn't need invasive intubation. So oxygen is hazardous because it's colourless. It is odourless. Any smell comes from the equipment being used. It's also tasteless. So is oxygen flammable? Oxygen itself is not flammable. However, it does support combustion. So if a patient puts an oxygen mask on their bed and the oxygen is still flowing, that bed space becomes an oxygen-enriched environment, which means there is a higher risk of it being flammable. Here are some incidents related to oxygen which have appeared in other trusts. An oxygen-enriched area is damaged phenomenally. In another trust, 6 patients die because the oxygen supply was switched off, and a dying man was badly burnt from a defibrillator. So there have been incidents in this trust related to oxygen where patients have been harmed because cylinders weren't used properly, oxygen wasn't used when it was available, and air was used instead of oxygen. So a patient came into the emergency department at Pinderfields after suffering an out-of-hospital arrest. Someone had put a flow meter in the air terminal unit, however the flow meter didn't have a black flap or black nipple on it. There was an oxygen flow meter above it. So when the ambulance staff came in with their patient, they attached the oxygen tubing to what they thought was an oxygen flow meter, but it was in fact an air flow meter. So the patient had a few seconds of medical air. and because of this, we had to declare it as a never event. Airflow meters should only be plugged in when they're in use. However, within Mid Yorks, we do not use airflow meters anymore. So if you find any, please return them to medical physics. If patients need nebulized medication via air, they need to use the air compressors, which are available via the equipment library. There's no way that an airflow meter can be put into an oxygen flow meter hole. They are not compatible. If your area has a medical air terminal unit and you don't need them, contact ENGIE or Estates and they will come and put a terminal unit plug-in to prevent the gas being used. Flow meters, particularly the double outlet flow meters, can be damaged when equipment is hung off them. This can also damage the terminal unit. There have been several instances where the terminal unit has been damaged, so you need to find other means to keep your equipment close by. The terminal units are designed so when there is not a flow meter in situ, medical gas will not flow. To enable the flow of medical gas, you simply push in the appropriate flow meter to the terminal unit. If you have a terminal unit plug present and you need to access that unit, you just need to contact an engineer to enable the plug to be removed. In an emergency, if there is gas escaping from the terminal unit, open the window to increase ventilation. If you've got a flow meter in the terminal unit that's broken, press the outside collar as you would to remove a flow meter normally to see if the broken bit will expel. If this doesn't work, the supply needs to be isolated immediately, so you need to contact ENGIE or Estates urgently and remove patients from that area. Prior to using a medical gas cylinder, you need to check that the gas within it's correct. So have a look at the collar and check that the medical gas is what you're expecting it to be. You also need to check whether it's in date and check the cylinder for damage. And if you do notice any damage, phone porters to have it removed and taken back to the gas store as a damaged cylinder. You also need to check the gauge to see if there's enough gas within the cylinder. A CD oxygen cylinder at a flow rate of 15 litres per minute, if that cylinder is full, will last 30 minutes. At a flow rate of 15 litres per minute, the vacuum insulated evaporator tanks, that's the two big white tanks which hold the liquid oxygen that are outside pharmacy. If those two tanks are used for one patient and one patient only, at 15 litres they will last nearly 2 years. This shows that the piped oxygen is not going to run out. However, inappropriate use of cylinders can mean that patients receive nothing because they've been left to run empty. A CD oxygen cylinder holds 460 litres of oxygen. So if it's full and running at 2 litres, it will last 230 minutes. If it's quarter full, it will last 50 minutes. If you have a patient that needs to go to the toilet and they're on 2 litres of oxygen, the cylinder is only quarter full, that should be ample for that patient. At 15 litres per minute, on a full cylinder, say it will last about 30 minutes. So if you're transporting a patient to another department, have a think about the journey. Think about whether they may need more than one cylinder. Will you need to ring where they're going to get them to get more cylinders? Plan ahead. Within Pinderfields and Pontefract in the near future, the F-sized oxygen cylinders, the black and white ones that are normally found on patient movement trolleys, are going to be replaced by HX cylinders. HX are a larger version of the CD cylinder. They're the same dimension as the F and they only weigh 2 kilos more. There's no need to purchase a regulator, and there's an integral valve with a constant live gauge showing the level of oxygen in that cylinder. They have a Schrader and Furtree outlet, so you can use the cylinders with oxygen tubing and also with the Schrader tubing. And there's no need for porters to hunt for the cylinder key. An F-size cylinder holds 1,360 litres of oxygen, so at 2 litres per minute, the cylinder will last 680 minutes. An HX cylinder holds 2,300 litres, so at 2 litres per minute, it will last 1,150 minutes. So these cylinders are the same dimensions, but you get phenomenally more gas. When cylinders are finished with, they must be returned to the medical gas store via porters. If they're stored on your ward, they must be secured in appropriate racking, and you should only store what you're going to need in a 24-hour period. If you do hold more than 24 hours worth of cylinders in your clinical area, that area becomes a ready-to-use store, which means full and empty cylinders must be kept in separate areas. There must be adequate ventilation via an external wall. You need to have safety signs, and the doors must be locked. The Trust only stores a certain amount of CD oxygen cylinders. So if a clinical area stores them, remember there won't be enough for the rest of the hospital. This means that patient treatment may be delayed because porters are then searching the hospital to find them. At the moment, there are about 200 missing cylinders. Are they in your cupboards? Are they in your toilets, your bathrooms? If you're not using them, return them to the gas store. When cylinders have been used in areas they may have been contaminated, for example by C. diff or COVID, they need to be decontaminated just like any other piece of medical equipment. BOC have told us that they can be cleaned with the green Clinell disinfectant wipes. You wipe the cylinder from the top to the bottom, but use extreme care that the valve outlets do not get wet. Cylinders shouldn't really be transported on a bed. They should be transported in cylinder holders. The Trust do have a few cylinder holders, but not many. So the Association of Anaesthetists have suggested that if a cylinder is needed to be put on a bed, it's set up prior and then put on the bed once the oxygen is flowing and avoid placing the cylinder next to the patient if at all possible. Patients requiring oxygen should use piped oxygen as a first line of treatment and transferred to piped oxygen from a cylinder as soon as possible. Medical oxygen is a drug and it must be prescribed and it must be signed for at drug rounds. If you have any queries regarding oxygen safety, please contact the Medicines Optimisation Nursing Team on midyorks.midyork.medstrain@nhs.net.